Hi, I'm Andrew, and this is part 7 in the Advent of Code series, where every day I'm attempting to solve a new code challenge. If I'm able to solve any challenge for the day, any code that I write, I'll upload to a public repository, and the link for that is going to be in the description. So I'm going to get started for today. The challenge is no space left on the device. You can hear birds chirping and raindrops hitting leaves as the expedition proceeds. Occasionally, you can even hear much louder sounds in the distance. How big do the animals get out here anyway? The device the elves gave you has a problem with more than just its communication system. When you try to run a system update, the following update, there's no space left on the device is the error. Perhaps you can delete some files to make space for the update. We need to browse around the file system and assess the situation and save the resulting terminal output, which is our puzzle input. So with this puzzle input, the file system consists of a tree of files, which is plain data, and directories, which can contain other directories in the files. So the outermost directory is called just the slash, and you can navigate around the file system moving into or out of directories. Within the terminal output, lines that begin with $sign are commands that we executed. So here we would be changing into the root directory. Here we'd be listing the files and getting the output. So basically just emulating, I guess, a terminal. So within the terminal output, cd is change directory. The specific result depends on the argument. So x moves in one level. By finding x, and it makes the current directory dot moves out one level. And the / moves to the outermost directory. ls is the list, which prints out all the files. So 1, 2, 3 space ABC means that there's 2 files. Oh, actually, it looks like the number is the size of the directory. Okay, so if there's a number, that's the size of the file. And if it says dir, that's the directory, and it's named XYZ. So given the commands and output in the example above, we can determine that the file system looks visually like this. Okay. Here there's 4 directories. We have the outermost, and then we have A, B, C. Oh, no, we have A. A and D. These are the outer, like the next level of directories, and then we have E inside of A, and yeah, those are the 4. The root, the 2 subdirectories, and then E. They all contain files of various sizes. We can see since the disk is full, our first step is finding the directories that are good candidates for deletion. We will need to determine the total size of each directory by grouping up the total sizes of all the files inside the directory, directly or indirectly. So if even though these files in the E directory aren't directly inside of A, they still contribute to A's total size. So the total size of directory E is 584. A has a total size of 94,853 plus I, because it's inside of E, which is inside of A. Got it. So a subdirectory is never going to be the answer because the directory, above it is always going to have at least that much. Um, but it still adds kind of one step of like recursively checking. And okay, so the outermost directory contains every file, so its total size is this. So to begin, we need to find all the directories with the total size of at most 100,000. Then calculate the sum of their total sizes. So in the example above, these directories are A and E. Because D is a lot larger, it looks like, so there must be a limit on what we want to delete. Okay. Okay, and in this example it shows that the files can be counted more than once because they are, it looks like this, yeah, the files can be counted more than once because the ones that they contain can also have them. So finding all of the directories with the total size of at most 100,000. All right, let's get started with that. Going to take the puzzle input, and this is our commands for navigating through the file system. Going to put this into our editor, and we got a little over 1,000 lines. So what we're going to need to do is parse each of these out into commands. So anything that starts with this $ symbol is going to be a command, and then anything that doesn't is going to be, like anything below will be the result. When we change the directory, we're not going to have any results. We will just be in that directory. When we list files, that's how we know what is inside of the directory. So it looks like the only real commands are changing the directory and listing files. And yeah, so that's all we should have to check. I'm not sure if it matters what these different file types are. Because all we're checking is the size, but I have a feeling for part 2 this might come into play. It seems strange that they would include different file extensions, but for part 1, since it didn't specify, I'm just not going to worry about it. All that I'm going to do is break each file, create a class to hold its size, and for each directory, just its name, I suppose. And anytime that we cd into a directory and list the files, we will need to add up like the files that are inside of it. So we'll probably want to model this out actually with just sort of a mock like classes for this. So it looks something like data class of directory, which has a list of files. Oh, whoops, we'll have a list of file, and we'll have a data class of file, which is a val name, which is a string, and val size, which I think we can assume is an integer. And What data class? Just so there's no confusion, I think I will name these. Um, we'll name these something. So we'll just say AOC directory and AOC file. And I think that's it. We'll also need to make our commands. So for this, we will have maybe a sealed class, which is command. And inside of it, we'll have objects cd, which extends command, and we'll have object ls. Actually, we'll name these change directory and list. I don't know what that stands for actually. List subcontents. Sure. They'll both extend command. But they will also need to have their own values. So maybe maybe sealed classes aren't the best for this, because for changing a directory, we need to know what the path is or what the file name is. Or we'll need to know what the directory name is. For listing, we don't need anything. Maybe we do. I suppose in an actual terminal you could have arguments with list, but it doesn't look like here. So we'll get started with that assumption. Yeah, I don't think a sealed class is the way to go here. I think we'll have data class, change directory, and that will have a value of path name, which is a string. And I don't even know if it makes sense to have a data class or any kind of class representing the list. Hmm. Oh, you know what? We could still use a sealed class, I think, for sealed class. And it's just the data class will um, will extend command like this, and the object of list files, we'll call it, will also extend command. This might work. So either one is a command, and we can probably have something on it. Maybe an execution function. No, I think we'll do that inside of our logic somewhere else, but I think I'm getting too ahead of myself. Let's just start by mapping each line into a step. So what we know is that starting from top to bottom is our commands. And then once we execute a list, everything underneath that is going to be the result. And then we're always going to change directory again and have a list of results. I suppose we could in theory, change directory down multiple times. Maybe that's, yeah, that happens here where we have multiple change directories. Here we go back up and then go to another one. So we can split out um, hmm, we're going to want to group all of these results after an ls um, in order to kind of assign them to the result of that command. We might just have to store each of these individually and then just iterate and kind of do our logic as we go. So I'm going to start with that. So for input one, input, we're going to map. So we have a list of strings, and each item is going to be one of those lines. So we can just say if it contains CD like this, then it's a change director command. Else if contains, oh, and we can actually just do a when here instead. When it contains $sign and CD, it's going to be a hmm. Well, so we've got two different types. We have directories and files, and then we've got commands. If we try to map them each here, we are not going to have the right right results. So I think we're not actually going to map here. We're not going to map commands or we're not going to map the files and directories that get returned like here. I think we're just going to take them and add them into the most previous answer. Okay, so maybe we'll need a list. Ooh, a list of. Okay, that's what we'll do. We'll make files in a directory a mutable list. So then what we'll start with is a value of, we'll have directories, and it's going to be a mutable list of directory, of AOC directory. So then we'll just do a for each on this, and we should always be able to be in the right spot to perform the operations. So if we go input for each, we'll just do different things based on what the result is. So we could still use a when and say when it contains a CD command, we'll do something. When it contains a ls command, we'll do something else. And when it contains, well, actually, that's really the only two results so far, I think. Either we're changing a directory or we are listing the items, or we're taking the items and then one at a time we can just put them into the last directory we created as files. And I don't know if we even need to add these, because if we're CDing, if we're changing the directory, we know that there's the directory, right? So I don't know that there's even a point in adding them until we change directory into them. I'm going to start with that. Maybe I'll regret it once we get going, but that's all we're going to do for now. So if we're changing directory, then we can say directories. We can add a new directory, new AOC. I'm already regretting this naming. AOC directory, and the files, it's not going to have any files in it yet. So we'll just create it with this. And since every time we create it, it's just going to be this empty mutable list, we'll just make that in the constructor. Mutable list of, and actually a better name here is just empty list. Empty list. Oh, but we can't know the type. Okay, that's fine. We'll just say it's a mutable list of that. And yeah, anytime we create a file, we should know the name and size. We'll leave those. So if we're changing directory, we will add it. Oh, and a directory has a name as well, or a path. So we will need to create that at least, and that's going to be, we're going to split by this, and we're going to take the second. Well, actually, we could probably just drop that. It's always going to be $CD plus a space, so we'll just drop that, and that'll give us our file name. And then we don't have to do any splitting. So we will take this and just drop. Oh, guess we can't do that. Remove prefix. So this will only take if it starts with it. And removing that, does it still give us the string of the answer? Yes, it does. So we just need another parentheses. So now that should be good. And what we're doing here is if we are listing out the files, then I don't even know if we have to do anything here, because the only way we're going to get these, right, the only way that we're going to get something that's not a command is if we call ls. So maybe we could even just not do anything for now. Otherwise, if it is not a command, that means it is a file or a directory. And we could check that whether it starts with this. So if else, so if it starts with dir, else, okay, so here it's a file, here it's a directory. Now this is this is probably why in file APIs directories are a file, because they can contain each other. But I think in this case a directory can contain a list of files and a list of directories. Just for simplicity's sake, because I don't want to make them share a parent at this point. Again, maybe that'll be a mistake that I come to regret soon. This is what we'll do. We'll just instantiate these with some defaults, and this is getting kind of long. So there we go. So a directory can have any number of files or directories. Okay, So if we always know that we're inside of the last directory that was added, unless we're going up, which could be a concern. So if we go up, well, anytime we go up, if we go cd up, the next thing we're going to do is cd into something else. I think that makes sense. So we can always go up, up. Maybe a stack would make sense here, where anytime we are moving down, we add to the stack, and anytime we're going up, we pop it again. But I'm not really sure how that would help us right now. Okay, so following this logic right now, we would be creating a new directory, just called root. It's the file name. We wouldn't do anything on this line. And then here, what we should be doing is creating a new file under root with this size and this name. We should be creating a directory under this path and just follow that down. Once we get here, by calling cd, we should be moving into that file. And I think we decided that we wouldn't do anything with this directory because figure out if it's necessary, but for now we're only going to add the files because currently we're adding it when we cd. Where this will become a problem is if there's duplicates, or if we go into a directory more than once, but it doesn't seem like that's kind of advanced enough for what they're asking us to do. In other words, I'm hoping that I can get away with some sloppy logic. So what we would do here is directories, take the last one in there and say we are adding files, and add a AOC file with we'll say the name and size are going to be from destructuring a split, which is splitting by a space. Because if we look at any of these files, size is the first thing and the name is the second. So if we do this, we have size and name, and we just put them, I think, in backwards order, so name and size. And size will need to be made into an integer. All right, actually, looking at this, it's already getting a bit too convoluted, and I don't really have a clear path as what I should be doing next following this approach. So I'm just going to take a step back and try to model out all of the behavior that this file system would need. So I'm just going to create that. I'm going to make a class for AOC file system, and I'm just going to make that something that I can interact with. I'm going to make it so that I just call a function on this for each of those steps and let it keep track of all of the different states of things instead of trying to keep, variables and stuff up here. So I'm going to say my file system is an AOC file system, and yeah, just go from there. I already have these mapped out to objects in some way, so we'll see if I can reuse some of that. But let's just go from there. What we would need to do is add behavior in the file system for a working directory. Directory. We can make that a string. Maybe it would be an actual directory. I'm not sure yet. But we will say list files is one command, and what that will do is add all of the results below. It will add each of these to what this will do is it'll add each of the results under ls. It will add them to its current directory. In fact, I might even just make that an AOC directory. And so under AOC directory, I will want to make a parent directory. This will not have a default value because you'll always need to create it or assign this when you're creating a new directory. Yeah. But I suppose it can be null. Just because if it's at the root, it won't have one. Oh, but the path will always have a line like this. Is it a forward slash? Yes. So a file system will always have a current directory, and then it will have a root directory. In fact, we could probably just make that the root. And we'll just create it with that root. All right, here's the root. So whenever we list the files, we are going to add all of them, add all files and directories to current directory. When we change directories, we are going to set current directory to either a child or parent. Because if we change our directory like this, we would just set current directory to whatever the current directory's child is with that value. So yeah, we could even do that. Current directory equals current directory directories. Find it path equals the path that is passed in. Okay, and this is going to be nullable, but I think we can just assert that we'll always find one with the right path. But we only want to do that if it's not up. So if the path is like this, Let me just make sure. Command. Okay, so we want to do $. So $cd up, and hopefully when we're changing the directory, we should already know. We should have already split this out. So we'll just say dot dot. Else we will just suppose if it could just be the slash, the /, we will say, is this reserved? Boolean. Oh, else if the path is this, we would say current directory is root again, or current directory is current directory's parent. And we can always assume that that's there. The only time that this wouldn't be there is when we're already at the root, and it shouldn't do that to us with our input. Then in the other case, we're not going to a parent, we're going to a child. It's going to be this logic. It'll tell us we can convert it to a when, I think. That's nice. Otherwise, we could also do lifting the assignment out and also doing the when. So that's maybe the best. Yeah, I'm fine with that. Maybe we could consolidate this a little bit better. Hopefully my formatter won't put it down again. Oh, it did. That's too bad. So for listing the files, we will take let's see. Yeah, technically we're not really listing the files from what we already have in here. We're more like populating our file system based on these commands. So I'm still gonna leave this. Actually, maybe I'll just change this to add file and add directory. And here's what we can do. We can have AOC file and AOC directory that we're adding. So something like this, and then under our current directory, we can look at the files and we can add our file. Looking at the directory, we could do the same thing. And we can add the directory. I think this will do a pretty good job at modeling. Once we're at the very end, we will just get the root. The root should be completely filled in with everything we've done, and then we can just run our logic on that. So let's go ahead and just do it. Okay, so back to our input. I think the logic we had before was actually fine. I guess we'll have to kind of redo some of that. So when it contains cd with the command cd like this, we will do file system dot change directory, and we'll say we're gonna it drop or it remove prefix that same prefix. Okay. And if what is it not like about this? When it contains something's not right. Oh, because we're not going like that. Okay, and when it contains ls, I think we know that that shouldn't really do anything. this just indicates kind of in our data set that that's what's going to be coming next, but I don't think this really matters again. When it contains, what did we have? We had, oh, we knew that in the else case, we could do this and say that if it contains a directory, that we're adding a directory, else we're adding a file. So in here, file system, we can add a directory and say it. I think we can just do the same thing where we just take, kind of remove that prefix like that. That's only adding the string. We need to add an actual directory. But maybe for this, we only need to know the name. I think that's what our file system can handle. So here, if we're adding a directory, we're only going to give it the string name. Directory name is a string. And, oh, it's a type of string. And what we'll do is we'll create an AOC directory. Its path will be directory name. Its parent will be the current directory. So like that. I'm going to get rid of this so we can see more of the screen. So we're adding directories. Now we need to add files. To add a file, we need to know its size and its name. Yeah, and we can already just pass that in. So under here, we would say file system add, do our destructuring again. Size and name is going to be splitting by a space. And we'll say add a file, AOC file by name, size with our integer. So earlier we had the right idea here. I think just using this file system to model all the logic a little bit better is the way to go. So let's do this, I guess, and just see what the file system looks like. Yeah, we've got all this logic in place, so we should be able to kind of browse it, assuming that I didn't miss anything. Okay, so what we got is a file system root, and we have a Stack Overflow error. Okay. I wonder what the problem there is. The current directory is ZMJ. ZMJ. That's kind of, yep, it's kind of down here. Yeah, that's the last thing that we added. So at least it made it down to the bottom, but Stack Overflow. Well, I think the only issue is trying to run toString on it. That's probably why. So we still have the files in the directories that it can handle. What we can do is look through these. Yeah, same thing. But that's fine. We don't need to run toString. Looks like we can just kind of go down the list. So if we look at dace, we look at this input under CD, we should have following directories under the root. Should have this first one with FM, FN, PM. When we go inside that, we should have a directory of this, FG, yep, Okay, so it looks like it's adding everything correctly. If we look at files, we've got each file with its name and its size. So maybe that wasn't as tricky as it looked. Now I could just put the logic in here to count up the size. Now, what was that? The rule for that again? It should be find all of the directories with a total size of at most 10,000. So when we're going through these, or this is 100,000. So when I'm going through these, just need to not count 100,000 or more. Calculate the sum of their total sizes. So here we've already filled our file system, and I'm just going to add a function for that. Fill file system. We'll do that down here to get it out of the way. And we'll say we have an input of a list of strings and a file system. Think that'll work. Just make sure again that it fills it out here. It looks like it did by the errors. Okay, so now the logic that we want is file system root. Yeah, this is going to be, I guess, kind of tricky as well as walking it. That's okay. We'll figure it out. I really want to make sure I understand what it's asking me before I start calculating this. So in this example, A and E, A and E Okay, so there's only 4 directories. Okay, and that makes sense. So D has way more than 100,000, so it's not counted. E has less than 100,000 because it has one file at 584, and A also has less than 100,000 because it has these other files plus that. Right. And then the root, of course, does not because it contains D. So first we need to just only find directories that have less than 100,000. So val filtered directories. Start here and just kind of write this. Okay. So now the question is just how do we filter those down in our file system? We will take the root and do some recursion, I suppose. And say, we'll say get directories under 100K. and it's going to return a list of directories. It's going to take a file system, and this will have its own recursive function. We'll just name it check folder children. And tail rec, so tail calls, it's going to always return itself by passing in the current directory. It'll actually have to pass in the children of it, I suppose. So our logic would be to get, let's see, get a list of AOC directories. We call this once at the top by returning check folder children of file system root. So I'll start at the top. First time we get in here, we're going to have the top level directory. And it's going to say if it's going to say if current directory files sum of the files size plus current directory directories sum of yeah, we might have to make a function for getting yeah, okay, so maybe we should have one of these that just gets the size of everything. Fun get directory size. Go from there. Return. We're going to do it the same way, pass in a current directory. And we'll just keep checking if the directories are empty, then we'll just return the file sizes. If current directory directories is empty, we're going to return the sum, but actually also if we'll want to return the sum of the files either way. We just don't have to go recursive on them, so we can go sum current directories. Oh, file sizes is current directory files sum of its size. So if the subdirectories are empty, we'll just return the file sizes. And this should be an integer for sizes. And if it's not, then we are going to return file sizes plus the subdirectory sizes. And I think we might need a list here. We could say maybe directories, subdirectories, which is a list. where we'd pass in a directory that we're on and the subdirectory is. Maybe we don't really need to do that. Yeah, let's see. I think we're close. Because we want to pass in. We need to continue moving down a level. So maybe we could just pass subdirectories. And if the directories are empty, yeah, so that makes sense because we're only going to keep going down if there's more directories, and the only point of a directory is the file size. So at some point, we're going to return up just the file sizes from each branch, which we're already doing here. So we shouldn't need to pass subdirectories because we can just get that from here. But there's our problem. So in this logic, we'll just continue passing in the same directory and getting its files. So maybe this just isn't a tail recursive function, and that's fine. So we can say current directory, directories, sum of getting the directory size of it. That's what I was trying to do. I was trying to force it to always call itself at the end, which optimizes the recursion, but for what we're doing, I think this is more appropriate. Yeah. So now we can always get the directory size, and we'll just say kind of going to do the same thing here, where we will just continue going deeper and deeper to get the size of each directory. And maybe that should just be a function on the directory itself. Yeah, maybe I'll just do that. Say get directory size. Get size. Okay, and yep, we'll make a private version of this and just a function for get size with no arguments, which returns an integer, and it will call get size. It is get size on this. Yeah, I think that makes sense. So from there, we've got a way to check the size of each directory, but now we still need to filter out which ones are over 100,000. So for that, we'll do this. I'm going to return a list of AOC directories, list of, we'll say directories, make a mutable list of AOC directory. Check folder, and we'll take the file system root, and we'll say, let's see, if We're also going to have a directory here. Directory. We're going to say if there is no subdirectories, then we'll return um, we only want to add to the directory's result if a directory has more than 100,000. So well, let's just add everything. Directories, add pair. It's kind of like recursion within the recursion because we need to go down one at a time. Almost like we need to just flat map these and then filter out by size. So we'll just say, yeah, we'll just say for each level that we go deeper, we'll just add all the children directory. The directories inside of it, add all, and if directories, the directories are empty, not empty, then we will continue calling check folder children. We don't even need to return anything here. We can just add it up to our list. I think we got the same issue as we had before, where it was only returning one at a time. So I think we need to do like a for each. Yes. So directory, subdirectories, I should really rename that. It's been getting confusing. Subdirectories. We're just gonna go for each and continue adding over. So once we're done there, we should have the full list. Yeah, so filtered directories is going to be, well, right now it's all get directories under 100K. So here we just filter, get size is less than 100,000. So let's debug that. Hopefully, it's not so inefficient that it can't run, but it can always be optimized from here. And we'll say file system root. Oh, do we just need the file system? What does this need? Yeah, just needs the file system. Right, we need to check folder children with file system root. Otherwise it wouldn't do anything. Okay, let's run this. See what we get. It failed. What did it fail? Could be a Stack Overflow. Or what is the problem? Yeah, Stack Overflow. looks like it just continued going in on itself forever. Yeah, I think we can do this. So it's tail recursion and it doesn't fail as bad. Um, and tail recursion is where it's you always call you always end with calling the function. That's not what we do here. This would be here. Check folder children. We would need a list of subdirectories. Um, Subdirectories. Let's do that. Directory. Um, don't even really need to return a single one. We'll always have a list. So subdirectories, we'll just always have this. So subdirectory is a map of its subdirectories. Maybe a flat map. Flat map. Okay. Here we still have we need a mutable list, but we have a list. It doesn't need to be a mutable list. It could just be like that. And then we already have our subdirectories. So what we'll just have to do is start out by passing in a list to this. And yeah. Subdirectories. I think I see the problem of what it had even before, in fact, is that um, I think it was just calling itself repeatedly. Mm, like folder children. Um, yeah, I'm going to undo this because I think that was actually the real problem. Because here, directory, we're always just checking the same one. We should be checking the subdirectories, which would be here. So subdirectory would be like that. And there we go. Try running it again. Maybe won't get the Stack Overflow. Cool. So filtered directories, this is how many do not have 100,000 or more. And if I look at this, I could probably find what they each are. Filtered directories, map, it get size. That should just return a list of the size for each one. So these are all under 100,000. So let me just sum them and yeah, go we get. Now this is actually terrible because we already just got the size to filter them. So I'm actually going to maybe not do it like this. I'm not going to filter them. we're just going to get the nested, um, get all directories, get nested, and just rename this. Call it that, and this is actually just the nested directories. The reason is I want to map them kind of in one go to it get size, and then filter anything under 100,000. So I'm not doing all that recursive logic twice. Is less than 100,000. Let's see. Get size returns an integer. Filter. Oh, we don't need to put a comma there. And then we'll just sum. Return that and see what our answer turns out as. Okay, we got, what is this? 1,491,614. Sure, that sounds like it could be right. Put it in our input. And we got the correct answer, thankfully. That all worked out okay. Couple hiccups, but I think modeling the file system was the right move overall. Let's go on to part 2. Now we're ready to choose a directory to delete. The total disk space available to the file system is 70 million. And to run the update, you need unused space of at least 30 million. You need to find a directory that you can delete that will free up enough space. Okay, so for the example above, the total size of the outermost directory, which is the total amount of used space, is 48 million. This means that the size of the unused space would be the difference. So taking 70 million, subtracting 48, we would get the 21. That's not enough available space. We need 30 million. Okay, so the update still requires a directory with a total size of at least 83 or 8 million to be deleted so that it can run. Okay, so we need to delete a directory that it's at least this big so that we can get over 30 million. We could delete directory E. That's not big enough. A isn't big enough. So the only two that we could delete is directory D and then the root. We need to choose the smallest. So D is the smallest directory we can delete that would still give us enough free space. Okay, so for our data set, we have to find the smallest directory where if we deleted, we would get enough. What is the size of that directory? Okay, so I think we can go ahead and start figuring that out. We're going to copy over some of the same logic. We'll just need to return it a little bit differently. First, let's set some of these values for referencing. So we'll say the system space is 70 million. We'll just do this so that it's easier to see. System space, and then 30 million is available space required is going to be 30. Oh, and I have a typo. There we go. Available space required. So then our used space is going to be the root of our file system. So we already calculated the size on all of them though, so we could just take our nested directories Um, and we can say, let's see, nested directories. Let's take these and just map them to their size, and then we can just sort them right away. So that in this case, when we loop over to find the smallest, we want them to be sorted from smallest to largest, but we do need to get the last item. That'll be the root, which is the largest directory because it contains all the subdirectories. So for used space, that's what we know is there. So we can figure out currently available space is going to be system space taking away our used space, and amount to free is going to be available space required minus our current available space. And let's just debug to see it as a sanity check. We'll set a breakpoint and see what those values all come out to be. Okay, so these look right. And so available space required is 30 million. Available space is 35 million. It shows. I don't think that could be right because then we wouldn't need to free up anything. Well, let's see. Amount to free. Yeah, so system space, used space is, let's see, that's 34 million is used. So we have 35 million available. Yeah, I guess that doesn't really make sense. Unless, let's look at the file system. File system should have a root size of 46. Weird. Why is it? Why is it not getting the size? Because here the root should be 46 million. So let's see. Let's see what's going on. Nested directories. There's 180. 180, and the very last one is this. So why? Why is it not including the last one? Yeah, that's really strange. Get nested directories. Even without this mapping, is it still just returning that amount? Let's see. I'm gonna get rid of those and just debug again. Okay, so nested directories, yeah, there's only 180 that are returned. And if I look at them, nested directories, max of its get size, the largest item it says is 34 million, but it should be able to count file system root get size, and that's 46 million. Okay, you know what? I wonder if it's just not, is get nested directories just not returning the largest one? And you know what? I bet it is. Bet that's what's happening. Yeah, so we're only adding, okay, so in our get nested directories logic, we aren't actually including the root in that list of directories. So that should be easy enough to change. I think we just start by um, initializing this with the root. Then we can clear out the type. And that should get us where we were. So yeah, let's try this again. I think it will fix why we weren't getting that. So I'll rerun the debugger. So now here the used space is now correctly 46 million. The amount to free up is 6 million. So that's where we need to do. We just need to find the smallest directory that's at least this large. And we can just check that. So nested directories, it's already sorted, and we can just take the first that is greater or equal to the amount we need to free. If we run that, it should give us our output. So that says 6,400,111 is the smallest file size that will get us, which sounds right. Let's try that input. And that is the correct answer. So that was a tricky one. The issue with that was that I didn't have solid logic for the first puzzle, or the first part, but I was still able to get the answer. So when I moved on to part 2, I just assumed that everything was already ready to use. So that was kind of my mistake that tripped me up with the second part. But I will just go ahead and clean up some of the code that I wrote and upload it to my repo. That's it for today. I'm at 14 stars now. Thanks for watching, and I'll be back tomorrow with another video.